Hi everyone, welcome to the video lesson for Monday, May 17th and Tuesday, May 18th. Today in class we were looking at the difference between weather and climate and how our human actions impact climate change. Remember, we only have a few weeks of school left, so please make sure you're getting in any late work. And remember, our homework this week is a little bit strange. You do only have one assignment, but it has been separated into two different assignments on Canvas. So make sure you hand in both. Your grade for this week's homework is going to come from both of those Canvas assignments. I do not sync my grades from Canvas to Synergy. I download it to an Excel file first, so I'm going to add it together before I put your grades into Synergy. Before we started our notes today on weather versus climate, we did have a warm-up. I wanted you to tell me, in your own words, how you would describe the difference between weather and climate. I'm very happy with the responses I got today. Thank you very much. As always, I love the ones that are slightly wrong. You guys do a great job because even though you don't really know the answer yet, and that's okay because this is a very speculative warm-up, I can tell that you're thinking it through. I can tell you're relying on that prior knowledge, and that's what I want for these warm-ups. I want you to go back and I want you to try. So thank you everyone for your wonderful replies. Here is the title page for this week's note packet. Notice if you go to page 2 of the notes, the table of contents has returned. And please, please, please remember, hit that little folder that says Move to make sure that you've saved this in your own chemistry folder in your Google Drive. Now I gave you this table of contents, so while you're taking your checkpoint, if you need a fast track to a certain part of the notes, you can do so. Now in class we started by watching these videos, but now on your own time you can open up your notes and watch them yourself. Our notes really started on slide number 4. So weather versus climate. Weather describes the atmosphere, the conditions of the atmosphere in a specific time and place. Weather can change rapidly. It all takes place in the lower troposphere, and it depends on the energy it's currently receiving from the sun. Weather is a very short-lived phenomenon that doesn't span that much of the planet at any given time. It can be sunny in the morning, rain in the afternoon, and then be sunny again. You may have even seen it rain while it's sunny outside at the same time with very few clouds in the sky. Weather is a very localized event. But climate, on the other hand, is a long-term average of weather in a particular location. It's very predictable, it's very steady, and it changes very slowly. We can describe it by air temperature, humidity, wind speed, direction, type, quantity, and frequency of precipitation. And it doesn't just depend on the energy that's coming in from the sun, it depends on the energy of the area. I would like to pull out an example of Greenland. Remember, Greenland is very icy and Iceland is very green. If you were to look in the closet of someone in Greenland, you notice a lot of cold weather clothing. Lots of long sleeve shirts, sweaters, jackets, coats, pants, boots. Lots of different clothes for very cold temperatures. But it doesn't mean it's below zero every day. If you lived in Greenland, there'd be warmer days, there'd be colder days. There'd be days when you need to bundle up with a very thick coat, days that you'd probably be able to go outside with a light jacket. However, the climate in Greenland is very, very cold. You would never go outside in shorts and a tank top and flip-flops. You would always be expecting a rather chilly day. And the opposite can be said of somewhere in the Bahamas. If you looked into someone's closet in the Bahamas, you'd see lots of shorts, lots of short-sleeve shirts. You'd see lots of clothes appropriate for very warm weather. Because in the Bahamas, in the Caribbean, it's a pretty warm region. You'd probably see a lot of rain gear too because it also tends to rain a lot. However, there are colder days and there are warmer days. I like to think about climate versus weather in that climate is what's in your closet, the types of clothes. We here in Maryland, we have 4 distinct seasons, so we kind of have a range of all 4. But if you tend to store clothes that you're not wearing during the season, you've probably already stored away all of your fall and winter clothes to make more room for your spring and summer clothes. Because we can predict, even though we don't quite know what the weather is for the next week, if you haven't looked it up, you know that mid-May, it's going to be in about the 70s. So you know how to dress for that. It can be colder one day or warmer. It could rain or be sunny. So you know to be prepared for those sorts of differences. But on the whole, in the middle of May, we know that it's going to be pretty mild. Then we chatted about these checking for understanding questions, mostly number 1 and 2. If you had a trip to go somewhere in December and you want to go to a warm location, you wouldn't necessarily be looking at the weather. You'd be looking at the climate. A lot of people said things like Florida, the Caribbean, Hawaii. We know that those places tend to be warm during December. We don't quite know what the weather is going to be like this far out, but we know it's going to be warmer than it would be in Maryland. So we're looking at the climate. But if I'm going to have an outdoor picnic this afternoon, well, I already know the climate in Maryland for the middle of May means, mid-70s or so. But I'm concerned about the weather. Would it be raining this afternoon, or would it be sunny? Here on slide 6, we have a graph that shows the temperature anomaly for the last 100 years or so. It shows the temperature in Fahrenheit and how many degrees above or below the average it was. Between 1900 and 1920, it was typically cooler than average. But since 1995 and beyond, this graph stops at 2011, but this trend does continue through 2021. Temperatures have been higher than the average. This change is from global climate change. Thanks to global climate change, we are experiencing more warmer than average periods than ever before. If you look back in time, we have a few years here and there of above average temperatures, but we also had a few years where there were below average temperatures kind of sparsed out between. We have not had a below average year since 1994. In most of our classes, we watch this short video on human impact in the environment, and I highly suggest that you do so now. So, some human impacts on the environment. Some of the reasons we impact the environment is because of our increasing population. There are more people alive on Earth today than ever before. The more people we have on Earth, the more resources we need to keep everyone alive and healthy and happy. Most importantly, we need more food. So having more people requires more food, which requires more agriculture. It requires a lot more land is dedicated to growing crops, raising animals. As more and more people enter the middle class, the demand for meat has increased, which means we're now raising more and more animals and livestock. And growing more plants has also increased the pesticides and herbicides that we use to try and kill weeds and kill pests that try to eat our plants. We have to be careful because these chemicals can go down into our water supply and can hurt other animals in the ecosystem that we don't intend to. For instance, it's widely believed that certain pesticides that we use may be contributing to colony collapse disorder, which is really hurting the honeybee population. Deforestation, clear-cutting forests has a huge impact on the environment. Remember, forests are really good carbon sinks. If we cut down all those trees, rather than taking carbon dioxide out of the atmosphere and storing it as biomass, it's now going to be releasing carbon dioxide as it decomposes somewhat. While we cut it down, we are burning fossil fuels and transporting it. So deforestation really, really hurts the environment. Urbanization, we're changing the landscape from what it is naturally, paving over it, building buildings. We take what is rather high of an albedo and changing it to paved surfaces and buildings, which has a very low albedo. This also changes the function of the land. In Ellicott City, in the last few years, they're having a lot of issues with flooding anytime there's a large rainstorm. A big reason for this is just uphill from downtown Ellicott City, they've gone through a lot of building. They've developed that land. It used to be hills and ground, and when it rained, all that rainwater would be absorbed by the ground and by the soil. Now that that ground and soil has been disturbed, built on top of, and paved over, when there's a big rain event, rather than being absorbed by the land, the water tends to pool and run down the streets and pools in the downtown area, causing massive flooding. We cause a lot of pollution, again with the pesticides and herbicides. It can hurt our air, it can hurt our water, it can cause things like algae bloom, which kind of sounds good, more plants in the water. But the problem with algae blooms is that they then tend to block out the sunlight, choking everything underneath it. Burning fossil fuels is our biggest one. We burn lots of fossil fuels for energy and for heat, and in the manufacturing processes. All of these human causes have huge impacts on the environment. We're destroying natural habitats for lots of different animals. This is directly related to our COVID pandemic we're currently in. As we encroach on wild spaces, those wild animals and humans are forced to interact more. This is very dangerous. This is how viruses and diseases can sometimes cross species lines. We are facing a loss of biodiversity. It's currently expected that we are facing a Holocene mass extinction event. Lots of animals around the world are facing extinction today. We're expecting many of them to go extinct in the next 100 years or so. And it's not just big ones that we can notice, like panda bears and rhinos. There are lots of small animals alive too that are facing extinction. Once those animals are gone, we don't know the full extent of how it's going to affect ecosystems. We could be seeing lots of ecosystems collapse. Climate change. Just about all of these things that we're doing are greatly changing and affecting our climate. Temperatures are getting warmer. Sea levels are rising. There are some nations in the Pacific Ocean, some island nations, that are being faced with the fact that they might sink. If the ocean rises just a few feet, well, the highest point of these islands are only a few feet above sea level, they're going to sink into the ocean. They're very concerned and they're very worried about their livelihoods, their homes. Ocean acidification is going to hurt a lot of fishing, a lot of species. Desert regions are growing. Soil erosion, again, if we're not careful with our land use, we can destroy the land that we are currently using. And then air and water pollution, that hurts us. The air in Beijing, China is so bad some days that they say walking around without a mask on, like a KN95 mask, is equivalent to smoking 2 packs of cigarettes. And it can also hurt the ecosystems. I just mentioned that if you use too much fertilizer, it can run off into streams, into the Chesapeake Bay, cause algae blooms, which can then lead to mass die-off events. On slide 9, there are 2 different videos embedded about wildfires and feedback loops. I also highly encourage you, yet again, to watch the documentary that's linked in the Bitmoji Classroom. It's click on that little Blu-ray case and right-click on it. It has an entire section just about wildfires, and a lot of what they predict will happen in the future, again, is stuff that has come to pass already. So wildfires is a very serious impact of climate change. The risk of wildfire depends on many different factors, such as temperature. It does need to be warm. Soil moisture is a huge one. Remember we learned about how water has a very high specific heat capacity? I could boil water in a paper cup. As long as there's water inside, it won't catch on fire. Moisture really helps prevent forest fires. So drought conditions really encourage forest fires. As long as there's some water in the soil and in the plants, It'll make it a lot harder for wildfires to spread. And the presence of trees and shrubs in a forest area really functions as fuel. And how good of fuel that is kind of results from the temperature and the soil moisture. All of those factors are either directly or indirectly affected by the variability of climates. So, like I've mentioned before, some climates have dry seasons and rainy seasons. That can really affect the soil moisture and the temperature. And by overall global climate change. Some places that never really had dry and wet seasons before are starting to have dry seasons. We are having fewer rain and extreme weather events, but they're becoming more forceful. So, although we might be getting the same average rain, or in this area, the same average snowfall each year, we're not getting it over a lot of different events. We don't have it snowing very often. We just get 1 or 2 big snowstorms a year. So in places like California, they're not getting less rain overall, but they'll have a long time without any rain and then get one big downpour and then go a very long time without rain again. Because of these longer droughts, we have drier and drier forests. Trees are dying and then drying out, and then they're just sitting in the forest waiting to fuel a forest fire. About 80% of wildfires in America are caused from human sources. Now, this is not necessarily due to people who have campfires and don't extinguish them, or people who smoke cigarettes and leave them in the forest. Although those things can spark fires, what normally happens is electrical wires. Indirect human activities are causing a lot of forest fires. The 2018 Camp Fire that went through California was caused from a substation sparking a fire. We have to be very careful on how we use our land and how we manage the forest. It used to be that anytime any sort of wildfire started, we immediately put it out. But we've since learned that some fire is good. It's kind of hard to judge what a good fire versus a bad fire, but as long as we can confirm that it was started or sparked by lightning, we tend to let it burn for a little bit. We keep it contained. And as soon as it starts to grow a little bit too much, that's when we put it out. We keep it manageable. We found that some trees actually rely on forest fires as part of their life cycle. And annual, smaller forest fires are good because it clears out the fuel that would otherwise build up. So those dry trees, those dried up and dead plants, it clears those out. So if there is a big wildfire event, there's less fuel for it to use. Because of global climate change, we're expected to see more wildfires and for them to expand. We then skipped ahead to page number 12, so we could talk about positive and negative feedback loops. Now, we've talked about positive feedback loops before. Positive feedback loops build upon themselves. It's kind of like sticking a microphone next to a speaker. You don't hear anything at first, but then that whine grows and grows and grows and grows. A positive feedback loop is something that continues to grow on itself unless something steps in to intervene. So if you leave a microphone next to a speaker, it's going to get louder and louder and louder until either the speaker is destroyed and blows out because it's too loud, or until someone moves the microphone away from the speaker. Last week we talked about sea ice. The world gets a bit warmer, so sea ice melts, exposing more sea water, which absorbs more energy because it has a lower albedo. Absorbing more energy causes temperatures to rise, which causes the sea ice to melt, which causes more energy to be absorbed, which causes temperatures to rise, which causes more sea ice melt. A positive feedback loop continues the cycle. A negative feedback loop does the opposite. A negative feedback loop slows or stops the cycle that created it. On slide 14, I wanted to point out our number one example real quick of a negative feedback loop. As temperatures increase, more humid water is going to evaporate from the face of the Earth. As humid water evaporates and is carried up into the upper atmosphere, it forms clouds. Clouds have very high albedos. So once those clouds are made, now sunlight gets reflected away. This has a cooling effect on the Earth. So now temperatures go down. So temperatures rise, evaporate water, clouds are formed, clouds then cool the Earth. This is a negative feedback loop. It does not build, it stops or slows the process that created it. And lastly, before we finished up today, we went to slide number 17 to chat about temperature units. We've talked before about Celsius versus Fahrenheit versus Kelvin, but now I'm showing you how to convert between them. Going between Kelvin and Celsius is pretty simple. You take the temperature in Celsius and you add 273 to find your temperature in Kelvin. If you have a temperature in Kelvin and you want Celsius, you just do the opposite. You subtract 273 from your temperature in Kelvin to get your temperature in Celsius. Now, converting between Celsius and Fahrenheit is a little bit more complex, but it's just fine as long as you're using your calculator correctly. So Fahrenheit is equal to 9/5 of the temperature in Celsius plus 32. So when you enter this into your calculator, please be very careful and very intentional in what you use. So open parentheses, 9/5, close parentheses, multiplied by your temperature in Celsius, close parentheses, plus 32. It really broke my heart when I was looking over a lot of labs, a lot of your calorimetry labs, and I could see that you had the correct work, you showed the correct work, but when you put into your calculator, you made some sort of horrible mistake, like you multiplied instead of divided. So be careful. Make sure you're not making those types of mistakes. Make sure you're very careful with your parentheses. Now, as an added little fact, if you have Fahrenheit and you want Celsius, again, you just do the opposite. You take Fahrenheit, you subtract 32, and then you multiply that by 5/9. Now, you don't need this for class, but I'm kind of curious to see if any of you guys can tell me what temperature are Fahrenheit and Celsius the same temperature. You can do a little bit of algebra here because they'd both be your value for x. And if you can tell me what that number is, I will tell you what's so special about that number. As you do your homework tonight and Wednesday night or Thursday night, please use your notes, please use your resources, and please, please, please remember that although you only have one homework assignment, it is divided between 2 different Canvas assignments. Until I see you guys on Thursday or Friday, be safe and make good choices.